Okay, this is our last section in this unit over classifying polygons. I think this is probably one of my favorite sections because we're going to talk about a whole bunch of different shapes today. So it's kind of cool. And on the front page of your notes there, I've got a big table for you once again to kind of compile your different definitions. All right, and we're going to go through these one by one and come up with some pictures for you too that you can draw next to them. All right, so let's talk about what a polygon is. Okay, a polygon is a closed figure, okay, that lies in the plane. So it's two-dimensional. Okay, so we're not talking about three-dimensional things. Okay, so flat things that lie in a plane, that's what that means. And it has to be closed. Okay, so I'll give you some examples here in a minute once you get these definitions down. So pause as you need to as I'm drawing them. Okay, but you can put a little example in that box to the right there of a polygon. So anything that has a bunch of different sides, it doesn't matter what it looks like, as long as it's closed, okay, then it is a polygon. Something that is not a polygon would be maybe like this. So that is considered not closed. And what that, another part of that definition that kind of links to that is that each side intersects exactly two sides. Okay, it has an endpoint. This one does not intersect at another side. Okay, so we would consider this not a polygon. Okay, so not an example. So the next thing we're going to talk about are convex and concave polygons. Okay, so a convex polygon is one that has or no line that contains a side has a point on the inside of the polygon. Okay, so an easy way to show that is just by drawing, okay, a shape. All right, this is a polygon that does not have a point on the interior of the polygon. All right, so here are all its vertices here. Okay, and there's nothing that's on the inside of that polygon. All right, so what is not convex, it has to be concave, and here's what that would look like. Okay, so let's take that same picture and imagine that I take this point here and I push it down. Right, so I'm going to try to draw that here the best I can. Okay, and then I push that middle point down. Okay, so here's all my points again. Okay, so I kind of flattened that or pushed it in. Okay, so that is a convex shape because this point lies in kind of inside what you would consider the polygon if I connected this one over here to this point here. So if I connected those two endpoints together, you can see that there's a point inside the polygon. Okay. Okay, so let's look at the next examples. Equilateral polygons. Okay, and equal angular polygons. So the difference there, one we're talking about sides, one we're talking about angles. Okay, so an equilateral polygon might be something like this, where you draw all those sides congruent. You can see one way I drew it looks a little bit bigger. Okay, but the idea is that all those sides are congruent. Okay, an equal angular polygon just means that all the angles are congruent. Okay, so those angles would all be the same measure. Okay, for a regular polygon, it just has to be both of those things, and it's convex. Okay, so it has to be equilateral and equal angular and convex. The best example of this is a square. Okay, so a square has 4 90-degree angles, so they're all the same, and it also has 4 sides that are all the same, right? That's how we would kind of draw a square, and a square is a regular polygon. Okay, so here's a square. That's a good example. Okay. Next thing we're going to do is talk about different names for polygons. All right, and so if we were in person, I'd be quizzing you guys to see how many of these you knew. Okay, so if we have a triangle here, okay, that's 3-sided. 4-sided is called a quadrilateral. We're going to do an entire unit on that soon, on quadrilaterals. Okay, 5 is a pentagon, 6 is a hexagon. A lot of these you probably know, okay, but some might be new to you. So I'm going to let you copy this chart down here. Okay, so we have triangles, quadrilaterals, pentagons, hexagons. 7 is called a heptagon. 8 is an octagon, like a stop sign. Okay, 9 is a nonagon. 10 is a decagon. It skips 11, right? 12 is a dodecagon. Okay, I'm going to throw 11 in there for you. Okay, so 11, if you want to add it to your chart, that's called a hendecagon. Okay, hen comes from, I believe, like a Greek prefix meaning 11. Okay, and then as we go bigger than that, there are names for these. You can look them up. Wikipedia has like a whole bunch, like up to 100, I think, or something like that. Or maybe not that far, but they have a bunch of them, and we really don't use them on a regular basis. So we'll call them n-gons. Okay, so for example, if we had like say a 36-sided shape, we would just call it a 36-gon. Okay. And so I put that note down there about the 11-sided polygon as well. Okay. So just a bunch of different names we can name things, and we're going to use these to classify different shapes here. So flip that over when you're ready. Pause if you need to get all those down. Okay. We're going to tell whether the figure is a polygon or not, and then we're going to classify it as convex or concave. So anytime you see a shape like this, like letter A here, that has something that looks like it's pushed in on itself, okay, that's a dead giveaway that you have a concave shape. Okay, so first we need to figure out, are these polygons or not? So polygon, let's say yes or no to each of these. So this one is a polygon. Okay, it's a closed figure. That works. B is not a polygon. You can see that we have a curved side here. Okay, so that is not a polygon. We only need sides that are straight. Okay, C is also not a polygon. Okay, because you can see here that there's 3 segments that meet at a vertex. Okay, that's not under the definition of a polygon, and we would say no to this one. Okay, the final picture here is in fact a polygon. Okay, in fact it's a pentagon. Okay, are they convex or concave? So this first one here is concave because it is kind of pushed down on itself. Okay, the other two we don't care about since they're not polygons. The last one is convex. Okay, there's no point that lies on the interior of the shape. Okay, so we would say convex. I think it's easier to recognize concave ones, and if it's not concave, it's convex. That's one way you could do this. Okay. The next examples here, number 2, is classifying these polygons by the number of sides, and then we're going to say whether they're equilateral, equiangular, or regular. Okay, and we're going to kind of give a reason to why. Okay, so first let's classify the type of polygon they are. So let's classify each of these. So 4-sided shapes are quadrilaterals. You know a lot of quadrilaterals already, like squares, rectangles, parallelograms, and you might learn some new ones when we get to that section, like a kite or a trapezoid. So that's a fun section or a fun unit, and we'll go through that in a little while. Okay, the next one is an octagon. Okay, 8-sided shape, and then the last one is a triangle. Okay, now let's say whether they're equilateral, equiangular, or regular. So if we look at the rectangle here, and this is a rectangle, but it's also quadrilateral. Okay, we see that all the angles are the same. Okay, so it's definitely equiangular. To be regular, though, the sides have to be the same. Okay, and we can see using these tick marks to kind of show us the opposite sides. The opposite sides are the same length, but they're not all the same length. Okay, so it's not regular, but it is equiangular. Okay, so that's kind of our justification for why we chose that. This octagon here now has 8 angles. You can see the 8 angles. They all have the same little arc in them. That symbolizes that they're all in fact congruent. Okay, so it is equiangular. All the sides have the single tick mark on them. That means that they're all the same and they're all congruent. So this shape is actually regular. Okay, if you look at any stop sign as you're driving down the road, stop signs are also regular octagons. Okay, all the sides are the same length and all the angles are the same. Okay, the last one here is the triangle. You can see by the arc marks inside the angles here, they're all different measures. Okay, since they all have different arc marks in there, they're all different measures. Same with the sides. They have different tick marks on the sides, so they're different lengths. Okay, so this would actually be none of the above. Alrighty. Let's take a look at our next example, 3 here. Okay, we can do a similar idea here. This is, in fact, a square, but we'll call it a quadrilateral. Okay, we're only worried about classifying it by sides right now. Okay, and it is regular. Okay, we can see that the sides and the angles are all congruent to one another. Now, number 2, this does not look like a shape we're really used to, right? However, polygons don't have to fit the mold of a typical shape we're used to, right? As long as they're closed, it's a polygon. So we can count the sides here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is a dodecagon. Okay, so it is a polygon. It does have a name, but it just doesn't look like a typical polygon. Now, is it regular? Is it equal angular? Is it equilateral? We know it's equilateral because all the sides have the single tick mark on them, right? We can see that going around the shape. So they're all the same size. But is it regular? Okay. Now, it's a little bit tricky because you can see that the angles here all have the 90-degree box on them. So all the angles that are marked there are, in fact, 90 degrees. One thing you can see, though, is it looks like this shape is pushed in on itself, right? So this is a concave shape. If we go back to our definitions, if you flip it back over on the front side, you'll see that a regular shape cannot be concave. It has to be convex, okay? Here's the reason for that. All right, that outside angle, we would call that like an exterior angle because it's kind of on the outside. These are all on the outside of the shape, right? But the inside, actually, in here, that's 270 degrees, okay? So it's a lot bigger than 90. All the other interior angles are 90, right? But every time you hit a corner there, you're getting a bigger angle. So they're not, in fact, the same angle. Okay, so this one is only equilateral. It is not going to fit the regular definition, okay? Example 4 here. So now let's throw a little bit of algebra in here. We have a regular hexagon, okay, and it says that the side lengths are as follows: 4x plus 3 and 5x minus 1. Find the length of one of the sides, okay? Since they're regular, since this is a regular hexagon, we know that all the sides are congruent, okay? We could put those marks on there. That means that 4x plus 3 has to equal 5x minus 1. Okay, so all we need to do is solve for x and plug it back in. Okay, so I'm going to subtract 4x from both sides. X minus 1 equals 3, and then add 1 to both sides, so x equals 4. Okay, so if I plug x in to, let's say, this side here, 5 times 4 minus 1, I get 19. A good check to make sure our algebra came out right is to go check the other side too. So 4 times 4 plus 3, that also equals 19. So we know that we got the right x value because the sides are in fact the same. All right. The last example here we have is number 5. It says that these two expressions represent the measure of two congruent angles in problem number 1. So let's find which is actually the example above. So find the measure of the angles. Okay, so if they are congruent, then we know they're equal to one another. So we can set them equal to one another. So I'm going to subtract 4x from both sides, and I get that 8 equals x minus 5. So add 5 to both sides, I get x is equal to 13. Okay, when I plug that back in up here, 4 times 13 plus 8 is equal to 60. Okay, and if we do that with the other expression, we can also verify that it's equal to 60 as well. Okay, which is good. These aren't on your notes. These would be something we could do for fun in class, but let's try a couple of them, and then I might leave a couple of them for you to try as well on your own. Okay, so let's draw a triangle that is not regular. So if something is not regular, it's got to have either some sides that aren't the same or some angles that aren't the same. So we could just draw a triangle here, like something like this, right? Okay, and maybe this side is the same as that one, but maybe this one's different. Okay, that would be an example of a not regular triangle, an irregular triangle. We could even say that all these angles maybe are different, right? That would also make it irregular. Okay, how about a concave quadrilateral? So when we think of a quadrilateral, we typically just draw a four-sided shape, right? But it's kind of hard to draw a concave one, okay? So imagine here, maybe on one of these vertexes here, these vertices, I push it in, right? So imagine I'm pushing in that side. So let me try to duplicate that. Okay, so if I have these other sides that I drew, okay, if I push that in, if I kind of, let's draw a dashed line here to represent where it used to be. So if I push that side in, right, my four-sided shape might look like this, right? If I shove that side in. So this shape right here, this green one, that could be a concave quadrilateral. Okay, it's got four sides and it's pushed in on itself. Okay, so there's a concave quadrilateral. I want you guys to try 5 and 6, and we'll touch base on those as well. So see what you can come up with, and that'll complete our notes.